Hello students, I am Isha Mendirata. In today's video, we are going to discuss a method of generation of ultrasonic waves using piezoelectric crystals, that is the piezoelectric method. We will also be discussing what are piezoelectric crystals, what is piezoelectric effect, how this effect is used in the oscillator circuit for generating ultrasonic waves, and then we'll be discussing the merits and demerits of this oscillator. So let's start. First, we'll discuss what piezoelectric effect is. What do you mean by the phenomenon of piezoelectric effect? So this effect says that when pressure is applied to one pair of opposite faces of a crystal like quartz, equal and opposite charges appear across its other faces. This phenomenon is known as piezoelectric effect. Now before I explain this, I would like to tell you there are some crystals available like quartz, like you have tourmaline, like you have Rochelle salt. Now these crystals, they have a property. Which property? When you pressurize these crystals, they give you electric charge. And generation of electricity using this concept is also known as piezoelectricity. Let's understand what this statement means. So this piezoelectric effect, here you can see three diagrams. See the diagram number A, which shows that there is a crystal in rest position. No pressure is applied. You can see the potential difference is zero. Have a look at the diagram B, which shows that one form of pressure, that is tension, is given to the crystal. That means you are elongating the crystal. You can see a potential developed between the two faces. And in the third, you can see that I am reversing the pressure. Instead of tension, now I am applying compression. You can see again there is a potential difference developed. To have a better understanding of what exactly this piezoelectric effect is, I'll show you an animation. In this diagram, you can see that this arrow, what is this arrow showing? The arrow shows that tension and compression. So I'm alternating the pressure, and you can see that the voltmeter shows deflection. That means voltage is generated due to the application of force or pressure. This is the meaning of piezoelectric effect. Now, if I use a piezoelectric crystal and I'm pressurizing it, leading to electricity, I can also use the crystal in a different way. Let's understand the other effect which is related to piezoelectric crystals, that is known as the inverse piezoelectric effect. In this effect, instead of pressure, we are giving alternating electric field. So if an electric field is applied to one pair of opposite faces of a crystal, corresponding changes in dimensions of other pair of faces of a crystal are produced. So electric field is applied to opposite faces of a crystal. That leads to changes in dimension of the other pairs. If the dimension is changing, that means my crystal is elongating and compressing, expanding or contracting alternatively. If this is happening, that means the area, the medium surrounding the crystal will lead to vibrations of a high frequency, that is ultrasonic waves are produced. Such an effect is known as inverse piezoelectric effect. Let's have a look at a diagram which will give you a better understanding. So here again I have three diagrams. The first one shows the crystal in rest position where there is no electric charge. The second shows that one polarity of electric charge is applied and you can see the crystal is getting compressed. When you reverse the charge, when you alternate the charge, you can see the crystal is getting elongated. That means the crystal dimensions are changing, resulting in vibrations, resulting in ultrasonic waves. To understand it in a better manner, let's have a look at an animation which shows that if reversing the voltage gives you vibrations in the crystal, you can clearly see that alternating voltage is actually changing the dimensions of the crystal. So this was what piezoelectric and inverse piezoelectric effect is. Now practically it is not possible to change the electric charge holding the crystal in your hand. So we'll be discussing a piezoelectric oscillator. An oscillator, you can say an oscillator is a circuit which leads to the alternating effect on the crystal, leading to changes in dimensions of the crystal, giving us ultrasonic waves. So it's a circuit which contains a plate of a piezoelectric material which is used as a generator of electric oscillations of a particular frequency. So basically, oscillator is a circuit which will give us alternating electric charges on the plates of a crystal. So let's understand the construction of this oscillator first. So there's a quartz crystal which is placed between two metal plates A and B. Why do we require metal plates? Because crystal is an insulator basically. So to give it alternating electric charge, we need metal plates or we need good conductors. Next, there are plates. The plates are connected to secondary of a transformer L3. So we have a coil L3 which acts as a secondary of the secondary coil of the transformer. When I use the word secondary, I mean to say that this is my output portion of the circuitry. You'll come to know once I move on to the diagram. Then we have coils L1 and L2 which form the primary of the transformer, and the coil L2 is inductively coupled to the base of the coil, and coil L1 and capacitor form the tank of the oscillator circuit. Let's understand what all these points mean. So in the diagram, you can see that there is a secondary coil. You can see the secondary coil L3. You can see plates A and B, and there is a crystal in between. There are ultrasonic waves shown. Now, if I have metal plates like this, so my crystal will vibrate like this. So ultrasonic waves are shown from the opposite sides. Now, moving on to the primary part, you can see that there is a coil L2 which is connected between the collector and emitter, and there is an LC oscillator. L1 coil parallel to C1 capacitor is connected between the base and emitter of the transistor. So this is the entire construction-wise circuitry of the piezoelectric oscillator. Now coming on to the working part. So first I'll explain you the working with the help of this diagram, and then point-wise we'll understand how a piezoelectric oscillator works. Now before starting the working, we know that the crystal should have the effect of alternating electric charge. Only then it will vibrate. Where is the crystal connected? The crystal is at the output end. And you can see that the primary and secondary, in between an insulation, this behaves like a transformer. And transformer secondary will behave the same way as the primary. So whatever is the charges, the polarity or of electric charges at the primary side, same will replicate on the secondary side. So suppose I say my upper end of primary is positive, my plate A will be positive. My upper end of primary coil is negative, my plate A will be negative. So starting with the working, you switch on the battery, current starts flowing through L2 and current magnetizes this coil L2. This coil L2 is magnetized, means the upper plate of the capacitor charges, and if there is positive charge, the same will be reciprocated, replicated on the secondary side. Now this positive plate of capacitor, once the capacitor is fully charged, what happens? It starts discharging through the coil L1. When the capacitor starts discharging through the coil L2, its upper plate becomes negative, and the same is replicated on the secondary side. I repeat once again, you switch on the battery, the current starts flowing through L2, it magnetizes the coil L2, and this current is now. You can see that the coils L2 and L1 are also mutually induced. So if L2 is getting magnetized, L1 is also getting magnetized. Due to the magnetization of L1, the upper plate of capacitor becomes positive and the capacitor starts charging. The upper plate of primary is becoming positive, that means the same portion, metal plate A on the secondary also becomes positive. Now this will continue till the capacitor is fully charged. Once the capacitor fully charges, it starts discharging through the coil L1. If the capacitor starts discharging through the coil L1, that means its upper plate becomes negative. The same is replicated on the secondary, that means the metal plate A becomes negative. Getting it? So this is how A was positive, then negative, again positive, again negative, and this is how alternating electric charge is exerted on the plates AB, leading to corresponding changes in dimensions of crystal. This gives us the vibrating effect of the crystal, giving us ultrasonic waves. The frequency of these vibrations can be adjusted with the help of the variable capacitor. Now, let us understand the working step by step. The first one shows that when the battery is switched on, the oscillator produces a high frequency alternating voltage, which is given by the frequency 1 upon 2 pi under root L1C1. This is the frequency of the LC oscillator. And according to this formula, if I want to change the frequency, I will have to change the capacitor value. It is difficult to change the inductor, so we take a variable capacitor. Now, this process generates an alternating EMF in the coil. This high frequency is fed on the plates A and B. Inverse piezoelectric effect takes place and the crystal expands and contracts alternatively, producing ultrasonic waves. Frequency of vibrations can be given by F is equals to P upon 2T under root of Y by rho. Because we have taken a plate, we will take thickness instead of length. P indicates the modes of vibration. Vibrating with maximum amplitude is known as the first mode. And then it's like you elongate a rubber band, it vibrates and then slowly it decreases. So this is the maximum amplitude vibrations, and generally the value of P is taken as 1 because we know that the crystal vibrates in its fundamental mode with maximum amplitude. What is Y here? Y is known as Young's modulus and rho is known as the density of the crystal used, the density of the material used. Next comes the process of resonance, the condition where two frequencies match. We know that when the frequency of vibration is equal to the frequency of alternating field, electric field, ultrasonic waves are generated. Thus, I can say F is equals to 1 upon 2 pi under root L1C1. This should be equal to F is equals to P upon 2T under root Y by rho. The first one is the frequency of LC oscillator. Second is the natural frequency with which the crystal can vibrate. According to the second frequency, first is adjusted with the help of a variable capacitor. So I would say that resonance is the condition where particularly ultrasonic waves are generated. Merits or advantages of this type of oscillator, that is of the piezoelectric oscillator. So it is more efficient than magnetostriction oscillator, the first type of oscillator which uses ferromagnetic material. So this is more efficient compared to this magnetostriction oscillator. Frequency as high as 500 megahertz, or you can say 5 into 10 raised to 8 hertz can be produced. Output is very high compared to the magnetostriction oscillator, and this is not affected by humidity and temperature. Why? Because it is not using any magnetic material. Instead of it, a piezoelectric crystal is used. Coming on to demerits, cost of oscillator is high because the shaping and the cutting of the piezoelectric crystal is a bit tedious job. Cutting and shaping is complex. That makes the cost of the oscillator high. Otherwise, if you compare it with the magnetostriction oscillator, it gives you higher efficiency, it gives you higher output as well as a very high frequency range. So this was about today's video, wherein we have discussed what are piezoelectric crystals, what is piezoelectric effect, what is inverse piezoelectric effect, what is a piezoelectric oscillator, how is it constructed, how it works, some merits and demerits of the same. Hope you have understood all the topics I discussed in today's video very well. Thank you.